So yeah, first of all, the structure of the economy is going to look at as follows. We had a discussion in class earlier, right? At period T, you have young is born, and then you have old. And T plus 1, you have young becomes old, and old disappear. Now you have new generation comes in, right? So on and so forth. So this is the structure of the economy. And then we use this overlapping generation model to understand, oh, sorry. We use this overlapping generation model to understand social security, understand aging population, how aging population affect, how aging wait, what happened? Oh, I see. Sorry, we use this to understand how aging population affects the social security system, right? Now, a few things start from easier one. So when the agent young, so they have income 150. So these are income. They have zero income when they old. Same here, 150. And zero income, right? And then so how the social pay-as-you-go social security system works. So when I'm young, I pay tax T, and when I'm old, I receive B. Right. So this pay-as-you-go just says, okay. So if oh, by the way, so here this is also another zero. This pay-as-you-go just says, if we look at this time period or any T, okay. So we are going to see all T we collect. All T we collect must equal to all the B we give up, or give away. But now the issue is the young and old, their size are different, right? But now so we have this population growth. Okay, so it means if we have one individual here or 100, and then so here, so old, sorry, yeah, here, so this is young. So we compare these two. And then so here we have 110 or 1.1, right? Because of population growth of here, 0.1, right? And then so this is just look at different time period. Now, if we look at same time period, and what we are going to get, so you have 1 here and here, so the size of the population must be 1 divided by 1.1, right? And then so this implies, so at each time period, so in terms of social security, so the equation must be 1.1 times T must equal to B, right? So that's how the social security is going to work. So 1.1, so that's the total tax revenue we are going to collect from young. B is the total benefit we will give away to old. And 1.1 just reflects population growth. The younger generation, their size is going to be 10% larger compared to old due to population growth. All right, so this is a social security system. All right, now what else we know? So actually, so here, so we add, we insert this preference. So this says consumer will choose C equal to C prime whenever it is possible. Okay, so this C and C prime, so in microeconomics, this essentially, they just refers to perfect complement. And these perfect complements or this particular preference actually characterize our preference over our left-hand side shoes versus our right-hand side shoes, right? So you always prefer one left-hand side shoes and with one right-hand side choose, right? So you want them to match with each other. So this perfect complement. And in the graph, so this preference will be look like as follows: C, C prime. Okay? And so this 45-degree line, and this is your preference. Okay, so if we have the same quantity, C versus C prime, whether you increase C along this dimension or you increase C prime, it won't change your utility, right? So the way you change your utility is you move to higher pair. Okay, so I believe you have learned that in your probably not in principle, in intermediate microeconomics, right? And so this is preference. Okay, any question? So far I just laid down the basics of the model to help you to understand how this model is set up or how we understand the economy. Is there any question regarding to the setup of the model? Okay. Now, the question first part asks you, okay, let me finish. There are no other taxes or government expenditure in this economy. So in that sense, this equation is going to summarize the government's behavior. And so this equation or this diagram is going to summarize households' behavior. Oh, by the way, so you should realize you should have a budget constraint, right? And then the households are going to choose a combination of C and C prime, such that you have this preference is going to tangent with your budget constraint, right? So the households, they're trying to maximize preference. Those are their preference. Okay, so they should move their preference away from the origin as further as they can, but they must be subject to their budget constraint. All right. So is there any question, or are we good? Any question?
Quick question, Professor. This might be a dumb question, but C here, is C just like, is that any type of good, or what type of good are we talking about?
Oh, so C, it just, so here basically is there's only one type of goods. So C just refers to what you consume in the current period, because everyone lives for 2 periods, right? Young and old. So C refers to what you consume when you're young, and the C prime refers to what you consume when you're old.
Gotcha. That makes sense. Thank you.
Okay. So maybe I will move to so this, I don't have enough room for this one. So let me use a notepad to explain these things. All right. So where we are, so we have young versus old, young, old, right? Old, young. Okay. So this is the structure of the economy. So when you're young, you have 150. When you're old, you have 0. So this is your income. When you're young, you pay tax T, and when you're old, you receive benefit. You receive benefit here, you receive tax, you pay tax. And here, 150 tax. You have 0, you pay B. Okay? And so the population growth is such that, say, for example, so the population is 100. And then, so here, so you're gonna have 100. And then so here, so you're gonna have 110. And then here, you're gonna have 121, right? And then so here, so you're gonna have 110 divided by 1.1, roughly like 90. Okay, this is approximate. So this is population, right? And then, so households, so their behavior is choose C equal to C prime. So you may want to write CY or CO, right? So because everyone lives for 2 periods. Okay, so I'm going to choose C equal to C prime. Now this is households. And so they're also subject to their budget constraint. So this is what we need to find out later. For the government, what the government trying to do is, so they have a social security system to finance. So social security system costs them B, right? Or you may want to write N of old. Okay, NO refers to the numbers of old people, and equal to NY times T. All right, but clearly NY divided by NO equal to 1.1, so that just gives you B, so that immediately gives you B equal to 1.1 T. Right, so these are two equations. Okay, so now let's see, so what else information we have to answer the first part. Where we are? Oh, it's here. Okay, so now part 1, find out the optimal consumption allocation in terms of B. Okay, so now we need to look at households budget constraint. Okay, so households budget constraint, so you can write two different ways. When I'm young, so I have C plus S. Right, C is my consumption when I'm young. S is my saving. So that's equal to what? Equal to my income, 150, and I need to pay tax. Now when I'm old, so let's call it C prime. When I'm old, okay, so I have no saving, right? Because I'm going to disappear. I'm going to die next year. So there's no point for save. I have 0 income, but I receive benefit plus B. Right? What else I have? I have saving 1 plus R times S. But if given here, so R equal to 0, so that just disappear, just S. And then so we can combine these two together. So what I'm going to have is C prime equal to B plus S. S equal to 150 minus T minus C. Right? So this is household's budget constraint. Okay? So households, so this is their preference, subject to this constraint. All right? So this is their preference and subject to this constraint. And in your microeconomics class, so you may write a preference like a maximize utility C and C prime, subject to budget constraint, like over here. But here, so I already give you the answer to this mathematician problem, right? But that's subject to this constraint. So essentially, you're going to use these two equations to solve C. So you're going to have C equal to C prime, and then equal to what? So you can easily solve this, right? So because you can move C over the left-hand side and divide to the right-hand side. Okay, so that's going to equal to B plus 150 minus T. Right? And this is also very intuitive. So 150 is your income when you're young. T is the tax you pay when you're young, and the B is the benefit you're going to receive when you're old. And we got interest rate equal to 0, so that's going to give you the net wealth of your lifetime, right? And then you're going to split between C and C prime, so that's divided by 2. Okay, so this is the first part. Now we look at second part. Suppose that the government levies a 20% of social security tax on young. Determine the social security benefit that would balance the social security budget. Okay. And then so here, so the key things we need to answer that part is the equation we just derived. Okay, let me write that. So 1.1 T equal to B. Okay. So where does 1.1 coming from? Coming from the population growth, right? At each time period, the relative size of young is 110% compared to old. Okay, so that's why we have this equation. But now here, so you have a proportional tax on Social Security. So that just tells you T equal to 20% times 150, right? Because the young, they have income 150. So they pay 20% of the tax. So that's the tax they pay. Now with these two equations, you should immediately find out B. All right? Any question? So you may try to work out this right now. So tell me, so what is B? Because we have two equations here. Anyone?
Is it 33?
45. Why is 30? Oh, wait, sorry.
33 too.
Oh, yeah, sorry. Yeah, so you're right, yeah. So T equal to 30. And yeah, 1.1 times 30 equals 34. Yeah, thank you. Okay, so now we move to C. Calculate lifetime wealth, optimal consumption, and saving under Social Security in V. Now let's just go to the node. Oh, wait. Okay, now we go to the node, right? So in this node, so that's the key. Okay, so we go to the next page. So C equal to C prime equal to 150 minus T plus V. And we just find out T equal to what? 20% times 150 equal to 30. And B equal to 1.1 times T equal to 33. And then so we plug in these two numbers back to here. You immediately find out C and C prime. Right? And then so with no surprise, you're going to find out C and C prime is going to greater than, or maybe I should write 150 plus 0. Right? But what is this? So this is your lifetime income without Social Security, right? Because so you have 150 when you're young, 0 when you're old, 0 interest rate. So they add them together, that's your lifetime wealth. Oh, sorry. So on the numerator is lifetime wealth. Divided by 2 is your optimal choice, right? So that immediately tells us this Social Security system will make everyone better off. Okay, so let's back to the question again. D, what would be lifetime wealth consumption and saving in this economy without Social Security? So basically I already told you, right? Because you have 150 lifetime wealth without Social Security. And then C equal to C prime equal to 1/2 times 150. That gives you C prime. And so from the calculation we just had, immediately you can see, so under Social Security, you can consume more compared to the case without Social Security. Right. So now we go to the loss part. Explain the impact of Social Security on welfare, consumption, and saving. Okay, so now we back to the calculation. We can compare. So we can finish the discussion by actually calculate this number. Okay, so C equals C prime. So now here is 150 minus 30 plus 33. So that roughly gives you 77.5 if I calculate correctly. No, 76.5. And here, so you have C equals C prime equal to 75. Okay, so now what that means? Now we go back here. Without, with. C equal to C prime equal to 75. C equal to C prime equal to 76.5. Okay, so this means C, sorry, yeah, is saving equal to what? Equal to 150 minus C equal to 75. Now here, saving equal to 150 minus C equal to 73.5. Right? And so now look at your lifetime wells, but clearly, so under Social Security, so you consume more than the case without Social Security, meaning, so you are better off. And you save less.
Why did you set that equal to 73?
This 150 minus C.
Oh, okay, okay.
So yeah, let's just make sure. So, because look at here. So this is your budget constraint, right? C. Wait a second. So apologize, I might not be correct. So we need to plug in. So this is your budget constraint. Now I just made it. I didn't calculate correctly. So C is 76.5 plus S and equal to 150 minus you pay tax of 30. Okay, and so your saving is less than that. Your saving is actually so your saving equal to 43.5. So with Social Security, you save 43.5. You pay tax of 30. And without Social Security, you save 45. You pay zero tax. Right? But now the last question is why this Social Security make everyone better off? Or why everyone benefit from this Social Security? The secret is the following. So under this Social Security, you pay $30 or whatever unit it is. And you receive, when you old, you receive 33. This implies this Social Security give you a implicit interest rate, let's just call it HUD, okay? An interest rate of 10%. But in the current model, under the market, we simplify, we say the interest rate equal to 0. So that's a secret. So this Social Security give you a higher return compared to the market return. In the current economy, the market gives you 0% return if you save. But with Social Security, because of the population growth, we receive a interest rate or rate of return of 10%. Question? Question. So that is why, so everyone benefit from this Social Security. Okay. Now we're back here. So that pretty much I explained to you how we solve this question. Okay. Now, so I would prefer just expand to your question and second question later. Okay, so I'll give you time to digest. Maybe in the break you digest a little bit, and then so I expand to you the second question later. Right. So now let me pause for a second. So we have how many group are we going to present today? 2 or 3? Who is presenting today?
We're going today. And I'm
We're
not sure
going
who else.
Yeah, we're the
Sorry?
other group.
Okay. So who wants to present first? And then you can share your screen.
Yeah, we can go first, my group, me and Ethan.
Okay. Wonderful. Let me just stop recording and then